For this problem, we're going to use the rational zero theorem to determine all the possible rational zeros of the given function. This is the P over Q function. Once you get into higher ordered functions, it becomes a little bit more difficult to solve them and figure out the solutions for them. So we use synthetic division a lot in solving higher ordered polynomial functions, but we can't just be testing random numbers with synthetic division until we find something that works. So listing all the possible rational zeros, this P over Q process, gives us a list of numbers that we can then play around and use synthetic division with until we find the correct solutions. The way that that works, you want to make a list that's going to come from P over Q. P is your constant, so for us that is a 35. Q is your leading coefficient, so think of it as the last number divided by the first number, and the first number is a 1. What you want to do is you want to list all factors of these numbers. So for 35, all factors of 35, list everything that multiplies to get 35. 1 times 35 is 35, and 5 times 7, that's really it. The only thing to get 1 is a 1 times a 1. At this point here, the next process in figuring out this list, you want to take everything in the numerator, put it over the denominator. 1 over 1 is 1. 5 over 1 is 5. 7 over 1, 35 over 1 is a 35. Put a plus or minus in front of each one of these because they can be positive or negative. This is the list of all possible rational zeros of the following example here. So last number over first number, find all the factors of it, write the possibilities out. So there are 8 possibilities of rational zeros for this particular equation.